All right, good afternoon, everyone. Today I'm going to be presenting on Blazor. In this presentation, I'm going to go over what Blazor is, um, what it looks like on a component level, what the two different hosting models are, and a little bit about where it's going. So what is Blazor? Blazor is an open source web framework by Microsoft. It uses C# instead of JavaScript. So if you're a C# developer, you can now reuse existing skills to create interactive UIs. So if you're someone like me who knows C# and very little JavaScript, this is really great news. Blazor has two hosting models. That's the client side and the server side. For now, I just want you to be aware of them. I'll explain them a little bit later. Blazor is part of the .NET ecosystem, which means you can reuse existing .NET libraries and you can share your libraries between the server side and the client side now. There are no plugins or code translation required to make Blazor work. Let's take a look at the history of Blazor. So Blazor was considered an experimental project by Microsoft in 2018. In 2019, a server-side Blazor preview came out, and then in September of the same year, it was released. In May of 2020, client-side Blazor came out, and then in November, Blazor was included in the .NET 5 release. In November of this year, we're expecting to see Blazor Desktop included with the .NET 6 release. So what we can get from this is that Blazor is still a very young framework. It's been in development for a few years, but for example, client-side Blazor has been released for less than a year, and it's being continued to work. They're continuing to work on it and improve on it. So with the .NET 5 release, we saw some performance improvements and some new features, and we expect to see the same hopefully in November of this year. Let's take a look at components. Components are really the building blocks of Blazor. And when I say components, I mean Razor components. So they use the Razor markup templating language to combine HTML and C# in the same file. This is then compiled into a .NET class when the project is built, and this .NET class is responsible for everything from the rendering of the component, the event handling, and lifecycle management. So it's quite a self-contained component. And then Blazor makes use of data binding to allow us to pass data through to the HTML. Blazor automatically will detect changes in properties and re-render the page as required. Of course, you can also do this manually if needed. For example, if it's outside of a normal UI event and your property has changed, you can just signal that by saying the state has changed. That's literally what it's called. The components don't render directly to the DOM. So they use a render tree, which is like an in-memory representation of the DOM, and they track changes against this render tree. They then use the diff between the render tree and the DOM, and only those changes, the minimum number of changes required, are applied to the DOM. So for server-side Blazor, this means you're pushing the minimum amount of changes required. Components can be nested, they can be reused, they can be shared as Razor class libraries or NuGet packages. So you have quite a few options. Let's take a look at a component. So this is actually the default component that comes with Blazor when you start a new project, but it's quite a simple example and it illustrates the points quite nicely. So this is the counter.razor. The purpose of this component is to, on a button click, simply increment a counter. So in this file or code snippet, you can see that there's a combination of HTML and C#, and we can see the Razor syntax denoted by the @ signal interspersed throughout. At the top of the component, we have a page directive. So what the router does is it intercepts all navigation requests and then will match it to the corresponding page directive. So if your component's not a page, it might not have a page directive, but if it is a page, it could have one or multiple page directives specified at the top. On the third line, we can see we have the @current_count. This is an example of data binding, one-way data binding, and then it will reflect changes to the current count from the code behind. The onClick method here then fires the increment count function, which will then increment the counter. So this is a very simple example, but it does, I think, nicely illustrates a few of the principles around this. Now, what if you want to use JavaScript? So I know I said up front that you don't need JavaScript, but the nice thing is you can use it if you want to. So Blazor supports JavaScript interoperability. So because JavaScript's been around for a much longer time, if there are any existing libraries or APIs that you'd like to use, you are completely able to, you're not limited in any way. So in this example, I've just recreated the increment count example using a JavaScript function to actually increment the counter. Of course, we know we don't need to use this because we've just seen it's very easy to do with C#. But again, this is just to show, to illustrate how easy it is to use JavaScript. So here, in order to use JavaScript in our components, we inject an IJS runtime. And then from that runtime, we just invoke the JavaScript function. So it is literally that easy. You can see here that it's an asynchronous method. This is to cater for a server-side Blazor. Of course, you can use the synchronous method if you want to only use client-side Blazor, in which case you would use the IJS in-process runtime and call the invoke on that. Again, though, it is recommended practice to use code that can run in either server-side or client-side Blazor, so they do recommend the asynchronous methods. Forms. So forms in Blazor can be done using HTML as per normal, or you can leverage Blazor's edit form. So the real benefit of using the edit form is it just makes data validation very easy, and it uses data annotations to do that. So with the edit form, you can see we've bound to the model instance person. I'm going to use the person in this simple example I've created just to do like a sign up form. So we're just looking for their first name, last name, email address, and age. So we have two method calls at the beginning of this. That's handle valid submits and handle invalid submits. So that just helps us, gives us options for processing the logic once the form is submitted with all the validations passed successfully or with them passed unsuccessfully. So the second line there is the data annotations validator, and that just hooks up the data annotations to the form validation, and then we can display a validation summary. So a lot of this, the rest of the code is quite standard. The input text is a Blazor component. It literally just will render as an input of type text. We've used two-way data binding to bind to the first name property with the @bind-value. And then you can display validation messages right underneath your fields as well if you want. Just to round off the example, here are the data annotations I used in the example. This is very standard and not Blazor specific, but you can set whether or not it's required and any restrictions or error messages that you want to set on it. Okay, so I've mentioned previously there are two hosting models for Blazor. Let's discuss the client-side Blazor first. So client-side Blazor runs on WebAssembly in the browser. This means that the compiled code is downloaded and run on the client side. We don't need to use a .NET server to host because it runs locally. Because we're using WebAssembly, it will run on all modern browsers, not obviously Internet Explorer, and the WebAssembly allows us to achieve near native performance. Because it's running locally, we could potentially run offline, but then the other thing to note is that we're downloading everything at once, so it's going to be a larger initial download. A final thing to consider is the exposure of client-side secrets. So for example, you wouldn't store your API key here. You would rather look at using something like a service API to provide data to authorized clients. On server-side Blazor is hosted on a server within ASP.NET Core app. So this makes use of SignalR, which is like a real-time messaging framework library, and UI events are sent to the server and the resulting changes are pushed back to the client. There's a smaller initial download, but we are able to use server-side APIs such as the Entity Framework Core. The app is running on the server, therefore it can be run in all browsers. We don't need to worry about only running in modern browsers. It cannot be run offline, and of course you might run into latency issues. So, if you're not sure how to make the decision between the two up front, if the pros and cons haven't convinced you, the good news is that at any stage you can easily transition between client-side and server-side Blazor. If you know that you might change your mind at a later stage, it's best to try and avoid using code that cannot run on both. So in the earlier example of the JavaScript interop, then you would want to use the async method so that it can run on both. So over here, I have just created a new project for client-side Blazor and server-side Blazor. This is just to demonstrate the similarities between the file structure for both. So you can see here under the pages and under the shared folder, we have all of the same Razor components from client-side in the server-side Blazor. And most of the differences between the file structure come from the fact that server-side Blazor is hosted within that ASP.NET Core app, which is then responsible for the additional files like the startup and the settings and having a host file instead of an index.html file. So again, it's very easy to transition between the two because all of the components are shared or reused between the two. So that is very nice. Then, as I mentioned previously, Blazor is still improving. So we can see that with the .NET 5 release, because Blazor saw a few new features and performance improvements. The performance improvements include it being 2 to 3 times faster on the Blazor WebAssembly runtime, and that was specifically for like complex UI rendering as well as JSON serialization. So a 2 to 3 factor improvement is quite significant. Then we have some new features such as CSS isolation. So this means you can now set CSS styles specifically on your Razor components, as opposed to sort of relying more on the global CSS files. And then we have new components. We have the input file and the input radio. So that allows us to handle file input and radio button inputs on the edit form. There's also virtualization of components, so you can choose to render only that which is in view as opposed to the full sort of page or list. Now we can lazy load assemblies and also manually set the focus. So that came out with .NET 5. We're hoping to see improvements with .NET 6 as well in November. And with .NET 6, as I've mentioned, desktop Blazor will be released. So in my opinion, the information on this is still a little bit vague, but there's a quote from Richard Lander basically saying that Blazor Desktop is going to, the purpose of it is to create hybrid client apps to combine like web and native UI together. So from my research, Blazor Desktop is going to allow developers to create Blazor apps within a native application container. It would also allow developers to integrate Blazor within a .NET app like WPF. I think that's going to be really interesting. So you would be able to take an existing WPF application and then have targeted pages or components or functionality that's done within Blazor. So I think that we can see that there's still quite a bit of work being done on it, and hopefully we'll be seeing more and more exciting features in the future. But I hope with this presentation you have a better understanding of Blazor and what it is if you didn't know, and that you will be keeping an eye on it and maybe trying to experiment a little bit on your own within it.